Hi, this is my lecture on chapter 3. Chapter 3 is called Describing Bivariate Data. The overview is here. Specifically, first, we're going to quickly go over ways to describe data visually. If you had, say, two variables. What is that? What do I mean by bivariate data? That means when you have observation, specifically you're collecting data on, let's say, people in the United States, and you collect data on two different variables: age, income, education, number of people in the household, etc. Two variables. That's what it means by bivariate data. And if you had a situation where at least one of them are categorical data, we could graph the data using pie graphs and bar graphs, okay? We could also graph the data if we have two quantitative data. Say we had income and years of experience, for example. And then I'll show you what to do if we had that type of situation. So this first section here will go fairly quickly. It's about describing the data visually using different charts, tables, and graphs, okay? Next, what we're going to do is talk about measures of association between these two variables. And this is when you have the two variables are quantitative, okay? Say income and years of experience or wage, years of education and wage of the individual, something like that. In this type of situation, we're going to talk about measures of linear association and three measures, which are covariance, correlation, and least square or trend lines. Okay. So the first thing we're going to do is section 2, which is visually describing observations of two variables. Okay. So let's suppose we had two variables and there's categorical data involved, maybe one or both. Okay. So what do I mean by when you work with two variables? As I said earlier, when you have when you're collecting data on individuals in the United States, you collect data on two different measures or variables of these people: age, sex of people in the United States, age of, say, ducks in California. That's another example. Of people around the world. Maybe that's the population that you can care about, people around the world. And you want to get their income and car, what type of car they have. Maybe your population of interest is people in Canada and salary and education. These are all examples of collecting data on two variables for each observation in our sample. Okay. So let's suppose you have one qualitative variable and one quantitative variable. Okay. Example will be education by country. Okay. If you have this type of situation, okay, we want to be, percentage of population less than high school, percentage population with high school, stuff like this. This is like education attainment, and countries will be US, Japan, and Canada. Okay. What you can do there is then you can visually provide this information using maybe a pie graph or a bar graph. Okay. So what I'm going to do is go over our first example of how to do that. Let's suppose we have data on two variables. One is qualitative or categorical, and the other is quantitative. Okay. And what I'm going to show you is how to create maybe side-by-side pie graphs and stacked bar graphs. These are various different ways, or even side-by-side bar graphs, various different ways of presenting information when you have one categorical and one quantitative. The example 3.1, we have professors' salary data, and we have categorical data for each professor as well. What is the categorical data? The categorical data is whether the professor is public or private, okay? And they could be also categorized as full, associate, or assistant. Now, other information we got from them is that we got their salary, okay? So we know several things about them. We know actually 3 things about them. One, what kind of school do they work for, public or private? In example 3.1, we'll know something else about these professors. Are they a full professor, associate professor, or assistant professor? So we collected 2 variables so far. And the third one is, how much money are they making? Okay. So we collected 3 variables basically about these professors. And with that type of information, one thing we could do is display a side-by-side bar chart, okay? So an example of it is right here. It shows that on the vertical axis, it shows how much money they make on average. On the horizontal axis, it shows 2 different information, whether they're full professors, associate, or assistants, and whether if it's full, they work for private school, public school, or private school, public school, private school, public school, private school. And you could see clearly from the side-by-side bar graph that public school professors make less than private school professors. So let's do some of this in Excel. That's why I have 2 screens open. One is Word and one is Excel. So let's do this. I'm going to copy this data into here. Give me some time. Public. So let's put data. And we have public. Let me boost it up a little. Private. And you have full, associate. I'm going to drop professor, assistant. And inside inside the table, we have the salary amount, 108.9, 127.8, 80.9, 84.5. These are in thousands, 69.2, 69.7. Okay. So we have this information here. And how can I make, or how can we make this side-by-side bar graph? One way of doing it is just to insert recommended chart right there. There it is. Okay. Press OK. I didn't even have to do anything. It's just the first recommended chart. There. There is a side-by-side bar graph. Okay. Just like this. Full associate assistant. This is fine. If somehow Excel switched out full, put it on this side, assistant on this side or something, the ordering, that kind of stuff to me doesn't matter. I know you could like click on these and manipulate it. For me, I don't care. Okay. All right, let's do another graph. Highlight everything, do insert. I saw other ones that we could do. We do a stacked bar graph right here. Press OK. And this is an example of a stacked bar graph. Okay, just ballooned it up a little. So here we talked about side-by-side pie charts, stacked bar graph, stacked bar chart. This is a stacked bar chart where one chart bar is on top of another. And you can see for full professor, blue is public and red is private. And you can see the red bar is bigger than the blue bar. Okay, so the red, so we could see privates make more money than public schools, professors. Same thing here. And here you could kind of see maybe the red bar is slightly bigger. It's kind of hard to tell. And here they look kind of equal. To me, if I want to provide information, this one maybe is not as useful as this one here. Okay, this one you could clearly see that one is okay. I think now I'm sharing the screen. I am so sorry. My Zoom crashed, and so it started up again. So again, here, this bar chart is probably a better presentation of the information than the stacked one. I'm going to try one last one. I'm going to highlight everything. Do say insert, recommend a chart, and see if there's a pie chart. No, there's no stacked pie charts. So I mean side by side pie charts. So the best way to provide that is likely you would have to manipulate the table, copy that information here. I'm going to delete these. Okay. Copy this here. So you have two separate tables. You highlight this one just for public, recommend it. Do this, highlight this. Okay, highlight this, guys, the privates. Do insert, recommended. And this to me would be an example of a side by side. Yeah, in an ideal world, you would have them together. I really don't care if you could do that or not. Okay. I think this the side by side bar chart is much more effective in presenting the information. All right, we're done with that. I'm going to delete. I'm going to go to a new page like that. Let's go to section 3, describing bivariate quantitative data using scatter plots. Okay, so what is a scatter plot? All right, so when you have bivariate quantitative data, that means both data are numerical data. So classic example of that would be like for people in the United States, you collect their age and weight. Another one would be income and years of experience. Okay, and what you do with this information is you could create something called a scatter plot. What is a scatter plot? Well, scatter plot is the following. Okay, I'm going to draw it here. Scatter plot, okay, is the following. It's created in this two-dimensional space where we have measured one of the variables, say x, and another variable y. Okay, and you just put the associated data here. So let's say x is age and y is weight. Okay, and you collect data on people. So let's say you have first person, second person, third person, fourth person, fifth person. So you have data on 5 people. and we collect data on their age and weight. Okay. So age, we have a 35-year-old, a 20-year-old, a 25-year-old, a 22-year-old, a 27-year-old. Okay. And the weight, we have 180, 175, 150, 180, 190. Okay. So then what a scatter plot is just plotting these points. So your first guy is 35, I don't know, age 35, maybe this is 35. And the weight is, I think I said 180. So this point right here, that's for observation one. Next person, 20 and 175. So that's 35. Let's say this is 20, 175, maybe like right here. Yeah, 0.2. And you just plot the rest of these. Maybe this is 3, 4, 5, 6, etc., so on. And you just try to see if you could figure out any trends using the scatter plot. Scatter plot is a very useful tool in seeing if there's some trends or relationship between the x-axis variable and the y-axis variable. And the way I plotted this one, it looks like there's like a positive relationship. You know, all the data points are kind of upward sloping, meaning as age goes up, weight goes up. Maybe that's true. I don't know. But it looks like it shows some sort of positive relationship the way I plotted it. Okay. All right. So let's keep going on this. That's what a scatter plot is. Okay. One variable is plotted along the horizontal axis right here. The other second variable is plotted on the vertical axis. Okay. The first variable is called the x. My example, that's age. The second variable is called the y. My example, that's weight. Okay. And all you do is plot the dots. Okay. This two-dimensional graph is called the scatter plot. Let's do this example here. Okay. Example 3.5, this. And let's see if we could just have Excel do the scatter plot on our behalf. So I'm going to clear this. Okay. And then let's put the data in. Data. And here's the observations. It's residence. And X is our square feet. Oh, I want some space. I'm going to double click right here like that. And then our Y is, I think it's house value, right? Yeah, selling price in thousands. Selling price. Okay, gonna open it up a little. And then I'm gonna, okay. That's okay. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I just hand typed it in. Another way of doing it is you do the 1 and you could say the next one is equal to the first one plus 1. And then you just copy this formula down. And we only need 12. So then I can erase these 3. Press delete. It's another way. There's a bunch of different ways you could create 1 through 12 observation numbers. Here, I'm gonna hand type them in. 130, 1360, 1940, 1750. Okay. Type these guys in. 305.2, 3288.6, 365.7, 425.3, 268.8. Okay, so this is our data. We have data on 12 homes. This is the square footage, and this is the selling price in thousands. So a 1,940 square foot home, $375,000. Okay, $375,700. Okay. So how do we create a scatter plot? One way we could do it is we highlight the data. Okay. Press insert, recommended chart. Hey, look, there it is. That's a scatter plot. So it's a scatter right here. Press OK. All right. So we have this chart. I'm balloon it up a little. How did I do that? I clicked on the corner, and then you can move and hold it down the left mouse key, and then you just move it. Okay. Now, one thing is our origin starts at 0, 0. But our data doesn't start at 0, 0. It starts right around here. So we have all of this dead space. We can make the chart more informative by getting rid of some of the dead space. So let's try that. I think you click on the axis, so these numbers right here, and you want to manipulate it. So when I click on that, double click on it, I get this tool that come out. And then you could see the bounds minimum. For the Y, that's the selling point. How the selling price. I don't need to start at 0. I could start at maybe around 200, maybe 100. Okay, and you could see you already fixed it. I'm going to click off it. Printing X. Now I'm going to change the Y's. I mean the X-axis right here. Click on this. See the numerical measures right there. Double click on it. And again, the minimum bounds, I'm going to switch it from the square footage. Start at, I don't know, about 1,000 maybe? 1,100? Let's start at 1. Okay. Get rid of it. And now we don't have such a big dead space. Yeah, we have a small one here, but you know, it's a more useful graph now. Okay. If there more information is provided, we don't have that empty space that kind of is useless. So this is an example of a scatter plot. Okay. What we can do is, given that we saw the scatter plot, just like I did when I was in my previous example, we might be able to fit a trend line. Okay. Right now, we see the dots are all kind of upward sloping. It looks like a trend line could fit through this. And what is a trend line? It's just a line that, and we're going to talk about this a little more later. It's basically a line that kind of shows us where the dots are, and if there's kind of there's a relationship between the x-axis variable, in this case square footage, and the y-axis variable, which is the selling price. And it looks like the dots are all moving upwards, okay, like this. So it looks like there's a positive relationship between square footage and the selling price. And that should make sense. The larger the home, holding all else equal, same location and everything equal, the larger the selling price. They should be positively related. So how do we fit a trend line? Okay. Well, here's the steps here. You right click on the dots, add trend line. And then they're going to ask you all kinds of fancy ones like exponential, logarithmic. Now let's do a simple, stupid one, just linear. You could make the trend line fancy looking by clicking on maybe, say, this button here, shadows, soft edges. This button shows, well, do you want to make it dash types or solid? then that's a solid line. What about the color? Do you want the color to be maybe black? Okay, maybe red. Okay. And then when you're done formatting it, oh, I want to make it thicker. Okay. Thickness. Oh, maybe it's width. Yeah, it's width. And then after you're done, just press X, and there's the line. And that's an example of a trend line that we created to that shows that there looks like that there's a positive relationship between the x-axis variable and the y-axis variable. Okay. Okay, now let's go to section 4. Measure of association between two variables. Here, what we're going to do is learn about covariance and correlation coefficient. So in this case, we're going to talk about usually two variables that are quantitative in nature. We'll go to a new sheet. Okay. Now, these two measures we're going to go talk about here. It shows the relationship, and basically I should have put in a word here. Linear relationship between two variables. Covariance and correlation coefficients provide the linear relationship between these two variables. Okay. What they do not show is causation. What do I mean by that? It does not tell you whether X causes Y to happen or Y causes X to happen. It doesn't show that X is an independent and Y is a dependent, or vice versa. Okay, it doesn't provide that type of information. Okay. What else it doesn't show? Oop, I gotta clear this. Is it doesn't tell you how much one variable moves when the other changes. Kind of what the slope does. Okay, so remember what a slope of a line does. Okay, so we have a line like this, and we have some y, and we have the x, and let's say the slope here, it's m. Slope here, the m, which is the slope, is equal to 3. And what the 3 tells us is that rise over run. It's like 3 over 1. So when x moves by 1 plus 1, y moves by plus 3. That's what the slope tells us. How much does y react to changes in x? If it's 3, x moves by 1, y reacts by increasing by 3. Covariance and correlation coefficient does not provide that information. It does not provide you how much one variable reacts when the other one changes. Okay, I'm going to clear this. Keep going. All right. So now let's talk about the covariance. Okay, covariance is the measure of linear association between two variables. It is not standardized. Okay, so it's difficult to compare the covariance of, say, age of people in the United States versus a weight of people in the United States. Two different variables. It's hard to compare their covariances. Okay, correlation coefficient, we will find out you can compare, but not covariance. Covariance can range from negative infinity to positive infinity. If it's positive infinity, if it's a positive number, so the covariance is positive, what you calculate is positive, then there's a positive relationship between these two variables, x and y. If it's negative, then it's a negative relationship between x and y. So what does the formula look like? The formula is here. And for sample, you use S, x, y is the sample covariance between two variables, x and y. And it's the sum of xi, the difference between each individual xi and the average times yi minus the average. You do that for every observation, and you sum them, and you divide it by n minus 1. This kind of looks like the variance formula, except for instead of doing xi minus average x squared, it's xi minus x bar times yi minus average y for y bar. Okay, for population, pretty much the same thing, except for we use sigma xy, not s, but sigma xy to indicate that this is for population. And you don't divide by n minus 1, you just divide by n, which is the total number of observations in the population, while little n is the total observation in the sample. And you have to subtract 1 because something called a degree of freedom. We will learn that in the later chapter. For right now, just God tells you subtract 1, right? All right, so these two are the covariance formula. All right, let's go to the correlation coefficient. I'm going to give you that formula, and then we're going to do them in Excel. And we're going to do it the easy way, where I use the Excel formulas. We're going to do that one in a second. And then we're going to do it the hard way, where we're going to apply this formula as well as this one. All right, so what is correlation coefficient? Correlation coefficient is another measure of linear relationship between two variables. It is denoted by R for sample and rho for population. R for sample and rho for population. Okay. Unlike covariance, it is a standardized measure. So you could compare across different relationships. Okay. So the correlation coefficient is between -1 and +1. And if it's very close to -1, there's a very strong negative relationship. If it's very close to +1, there's a very strong positive relationship association. Okay. So what does it mean by negative linear relationship? It means when x goes up, y goes down, or x goes down, y goes up. Positive linear relationship, x goes up, y goes up. X goes down, y goes down. They both move in the same direction. Okay. If there's no linear relationship, the value is close to or equal to 0, Very weak relationship, close to 0. Very strong relationship, close to 1 or -1. All right, so what is the formula for correlation coefficient? It's right here. It's Rxy. The correlation coefficient between x and y is Rxy is equal to Sxy, which is the covariance between x and y, divided by Sx, Sy. Sx is the standard deviation of x. Sy is the standard deviation of y. It's right here. Rho xy is the correlation coefficient for the population between x and y. So, and that's equal to sigma xy. That's the covariance of the population between the population x and the population y, divided by sigma x times sigma y, where sigma x is the standard deviation of x for the population. Sigma y is the standard deviation of y for the population. All right. So if you have a sample, let's say the population is all people in the United States. You want to know what is the linear relationship between age and weight. We don't have money to collect data for everybody in the United States. We get a sample of 1,000 people from the United States. Then we use this. And we use this. But somehow we are able to collect data on everybody in the United States. Maybe it's a census. Then we use this, and we use this. Again, what's the difference? The only difference is here n minus 1. Obviously, if our sample is super large, n minus 1 doesn't really mean much. The minus 1 is nothing. All right. Let's keep going. Okay. Positive pattern, negative pattern, no pattern. Okay, yeah, that kind of makes sense. This looks like there's positive relationship between X and Y. This looks like negative. And again, this looks like a big cloud of bubbles, no relationship. Here are some other visual examples. When the correlation coefficient is -1 or +1, all of them are on the same line. Okay, doesn't tell you what the slope of the line is, it just says they're all on the same line. If it's about 0.9, okay, and they start getting off the line. 0.5, we could still see a positive relationship, but they're clearly off the line. 0.1, yeah, I guess it's positively related. Yeah, it kind of looks positive, I guess, but it looks more like a big bubble. Okay. Now let's go back to this example here, okay? And let's calculate the covariance and the correlation coefficient. So first, what we're going to do is use the formula, and we're going to calculate covariance right here. So I'm going to go to this tab where we already punched in the data, and I do not want to punch it again. So I'm just going to highlight everything, press Control-C for copy, go to a new tab, click on A1 and press Control-V to paste. I just increased it, zoomed in so you could see it. All right. So now let's calculate this correlation, covariance. And we're going to do it the long way first, and then we're going to do it the easy way using Excel. To calculate covariance, I need xi minus x bar. So let's just put that in, parentheses x underscore I minus, x underscore bar. Okay, close parentheses. The next thing I need is parentheses y underscore I minus y underscore bar. I'm just labeling it this way. You can label it a different way if you need to, if you want to. Okay. And then the next thing we got to do is multiply this dude times this dude. And for simplicity, I'm going to just say D times E because I'm lazy. All right. In order to do these, I need the average of X and the average of Y's. Remember, this one right here is X, and selling price was Y. So let's label it. All right, to get the average, we have to remember from our formulas from previous chapter, this is equal to average. Open parentheses, highlight all the data, close parentheses. That's the average. We'll do it again for Y. What I'm going to do is just press Control-C, copy, Control-V, paste the formula over. And I want to make sure it's copied over correctly. So I'm going to double click on this formula, and you can see what it's highlighting. It's highlighting the cells that I wanted to highlight. So the formula did work correctly. I'm going to highlight all these variables, all these numbers, and I'm going to click on these to standardize all the decimals. Yeah, let's do 2 decimals. That's just formatting, nothing more than that. All right, so to calculate xi minus x bar, it's equal to xi is that one. The first x is x1 is the first x. x1 is the first x minus the average right here. And I'm going to anchor B16 so I could copy the formula down. And remember, anchor is double click, okay? And press F4 to put $B, $16. That quote unquote anchors it, and it doesn't allow B16 to move. Press enter, okay? Now what I'm going to do is press Control C to copy, highlight where I want to copy to, okay? Press Control V and it should have copied the formula down correctly. Just in case, we'll check one. Yep, this one minus that, okay? I'm going to do the same thing for the y's, equal to this guy minus this guy, and I got to anchor this guy. So I'm going to press F4, anchors it. Or you could just do $C, $16, enter. Highlight this guy again, Control C. Highlight the cells you want to copy to, Control V. Check one just in case. Check another one if you need to. Okay, did it correctly. So we have here xi minus x bar, yi minus y bar. We need to multiply them together. That's what we're going to do here. Equal to this dude times this dude. Enter. Yep. I'm going to press Control C to copy that formula down. Control V. Again, there's other ways you could do it. Okay, if you don't know how to do Control C, Control V, just press equal to this guy times this guy. And then see that green little thing right here? Click on it, drag it down, let go, copy the formula down. There's many different ways to do this. And then, all right. So this is xi minus x bar times yi minus y bar. Okay, so we did this for each observation from 1 to 12. Now we got to sum them. So let's do the sum, or the total, equal to sum, open parentheses, highlight all the numbers we want to sum, close parentheses, enter, and there it is. Okay, so that's basically our numerator. So to calculate covariance, well, that is equal to the numerator divided by the denominator, which is 12 minus 1, n minus 1, which is 12 minus 1, or 11. And there it is. That's the covariance. Okay. Now let's do the correlation coefficient, which is this is right here. Okay. And to do this, we need the covariance, which we calculated, and we need the standard deviation for x and y. Okay. This is equal to, we learned this already, STDEV dot S for sample, open parentheses, highlight all the data. Oops. Not the mean and not the title. Close parentheses, that's the standard deviation for x, equal to STDEV dot S, open parentheses, highlight all the data, close the parentheses, that's for y. So now to do correlation coefficient, well, this is equal to the covariance divided by this dude times that dude. But this, both of these have to be in the denominator. So I'm going to do a parentheses because I'm paranoid. This dude times, which is asterisk, this dude, close parentheses. And I got this as the correlation coefficient. and this as the covariance. I'm going to highlight this row and bold it so it's easier to see. I'll zoom in so you can see the numbers easier. All right. So I did this the quote unquote hard way by calculating this. The easy way is to use the Excel formulas for covariance and correlation coefficient. The Excel formula for covariance in a sample is covariance.s, and then you put in x's and y's. If you want to do population, it's .p. For correlation coefficient, it's just correl, and you put in x's is the first array, comma, the second array is the y's. All right, so let's do this. Equal to covariance dot s, because we're doing sample, open parentheses, highlight the x's, 1 through 12, comma, highlight the y's, 1 through 12, close parentheses, same number. Okay. Let's put them at the same decimal place to show you it's the same. Yeah, it's the same number. Correlation coefficient equal to correl, open parentheses, highlight the x's, comma, highlight the y's, close parentheses. There it is again. And let's do same number of decimals to make sure it's the same, like that. How do you make 100% sure they're the same number? Equal to this number, equal to this number. You're asking Excel, are they the same? If it comes out true, they are the same. Equal to this number, equal to this number. Are they the same? It's false. Why is it false? Okay, maybe those are rounding. That I don't know. Let's see where they differ. Well, they don't differ to there. Oh, yeah, right there. Okay, so technically they're slightly different. But I think they're close enough for most of us. All right. All right. So that's correlation coefficient, that's covariance. The next part of this chapter is the least square. I'm going to start that in the next recording, and we'll call it a day for this recording. So I'm going to close up shop now.